Okay, today we're doing the binomial theorem, and we're going to revisit some things you should have learned in algebra. And hopefully by the end of the class period, you will see a shortcut and wish you had learned that in algebra instead of doing all the long math. Okay, so I have Pascal's triangle up here. Can I get a volunteer to fill in this row right here, the one that has the 1 and the 6? Who wants to come and fill it in? Go ahead. And then if we can get the pen going, and I would like each row to be a different color. Okay. Oh, click on pen. Sorry. So you should have 1, 4, 6, 4, 1. Who wants to do the next row? Who wants to do the next row? Thank you. Okay, 1, 5, 10, 10, 5, 1. I heard a couple people ask, how are they getting the answers? Who can explain that to me? What are they doing? The numbers touching in the shape. All right, the ones that touch, they form this one, so this is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. See how that works? Okay? So, who would like to do the next row for me? You can do the one after. Thank you. I'm sorry, I'm switching because it's a lot. It's a busy page. I'm trying to switch the color so you can distinctly see each row at a time, okay? Okay, so 1 plus 5 is 6. 5, is it acting up again? Yeah, it's being very temperamental. Let's see if I can get it to register again. Okay, so 20, there we go. So, all right, we have 1, 6, 15, 20, 15, 6, and 1. Herdine, I believe you said you'd do the next row? Just don't press the button on the pen. That's part of what's been making it act funny. All right, so 1, 7, that's a 15, yeah. So 6 plus 15 is 21, 35, 35 again, 21, 7, and 1. Once you hit the middle, then it's just increasing, decreasing. That increasing, decreasing will come into play later. Who wants to do the final row for us? Go ahead. That increasing, decreasing will come up again in a second. There's lots of repetitive patterns. 1, 8, 28, 56, oh, no, 70. But that's not what you said. 56. Oh, okay. 28, 8, and 1. Good job? Yes? All right. Shh. Let me adjust the screen. Thank you. Shh. Now, last week we studied the following using the graphing calculator. Okay. Shh. Thank you. 4 combination 0. 1. 4 combo 1. 4 combo 2. 4 combo 3. 4 combo 4. 1. Calculator. Oh, because they did it before I start going over the answers. Okay. 5 combo 0. 5 combo 1. 5 combo 2. 5 combo 3. 5 combo 4. 5 combo 5. 1. All right. So, What do you notice about this 4 combo and Pascal's triangle? It's the same pattern as? Right, it's the same pattern as Pascal's. It matches up with this row right here, and then the next one matches up with this row. Just so you know, looking at Pascal's triangle, the top, which is the 1, that is actually x to the 0. The next row is x1, x2. So the fifth row is actually the power of 4. Good? All right. Go ahead and turn your paper over. I would like you to do problem number 4. You should have learned how to do that in Algebra 1. You need to write it out. You need to FOIL or double distribute, however your teacher taught you, until you get to a simplified answer. Number 4 on the back, please. Okay, so let's look at this. To write it out, it is a plus b times a plus b times a plus b. You do the first FOIL, a times a times b times a, b times b. After you do FOIL of the first two parentheses, you get a squared plus 2ab plus b squared when I clean that up. I still need to multiply it by a plus b. So I'm going to share a with each one of them. Okay? No, this is not simple. I'm going back to how you learned it in algebra, and then I'm going to show you how pre-calc makes it simpler. A to the third plus 2a squared plus, 2a squared b plus ab squared. All I simply did is share a with each of the 3 terms. I'm now going to come back and share b with each of the 3 terms. So that is a squared b plus 2ab squared plus b to the third. Now, I am going to look for like items. I only have one a cubed. There is no other term that has an a cubed. So I'm going to write a cubed, and I'm done with that one. I'm looking for an a squared b. Right here is an a squared b. 2 plus 1 is, how do I know that this is a 1? Right, it's understood if I have just variables that the coefficient is 1. So plus 3a squared b. All right? My next one is an ab squared. And I have another ab squared. What's my total? 3ab squared. And then I have the lonely b cubed. Okay, listen to my question, because some other students, oh no, sorry. Okay, now what I want you to do is a plus b to the 4th. Add it to the bottom of your paper. Now, you might freak out and say this is a lot of work, but it's not. This is the answer to a plus b cubed, right? So the 4th is just multiply this by a plus b again. Okay? So add to the bottom of your paper this problem, a plus b to the 4th. We're going to take our previous answer of a cubed plus 3a squared b plus 3ab squared plus b cubed, and we're going to times it by a plus b to get that 4th. So try that now, please. Okay, so let me show my work. Again, I'm going to share a with everybody. And when I share a, I get a to the 4th plus 3a cubed b plus 3a squared b squared plus ab cubed. And then I'm going to come back and I'm going to share b with everybody. And I get plus a cubed b plus 3a squared b squared plus 3ab cubed plus b to the 4th. Sorry, I wrote big, so it curved around the board. Do I have more than one a to the 4th? No, a to the 4th. I'm looking for a cubed b. There's a cubed b. There's a cubed b. How many? 4. Now I'm looking for a squared, b squared. A squared, b squared. A squared, b squared. How many a squared, b squareds do I have? 6. How many ab cubed? No. 1 plus 4. 4ab cubed. And then finally b to the 4th. Now listen to my question. Okay? I want you looking. So this was to the 4th power. I want you to look at the powers only. So the exponents only to each term. Tell me when you notice something. Okay, there's a pattern, a sequence. Yes, I want to hear something before that. You are correct. I want something before that. Remember, if it doesn't have an exponent, the exponent is 1. Okay, so if that helps, I'll put that in there. Yes. No, I don't want the coefficients, only the powers. Okay, when I add the powers, they always total to 4. Then I heard the sequence and the pattern. It goes, the first term goes 4, 3, 2, 1, 0. And the second, so it decreases. The second term goes 0, 1, 2, 3, 4. It increases. Now, what can you tell me about the coefficients? They match Pascal's triangle. If you look at the 5th row of Pascal's triangle, it goes 1, 4, 6, 4, 1. Something, yes, we're going to do an example in a second. Okay, so we are now going to do one together using Pascal's triangle. Now, if I made you write that out, we'd be here all day. Okay, so now I'm going to show you the quick, fast way. Okay, x to the 8th is really the 9th row of Pascal's triangle, which happens to be the bottom row of your Pascal's triangle. Can someone please read out the coefficients? 1, 8, 28, 56, 70, 56. I write big, so mine's continuing, sorry. Plus 28, plus 8, plus 1. Okay? That's the first thing I do. I write the Pascal coefficient. Good? Then I go back, first term. What's the first term? A. So I'm going to do a to the 8. A to the 7. A to the 6. A to the 4. A to the A, and then no A. So now I typically go backwards now. So I'm going to go backwards. What is the second term? B. So B to the 8. B to the 7. 6. 5. 4. 3. 2. 1, and 0. Okay? And I can double check my work because these two numbers better add up to 8. 7 plus 1. 6 plus 2. 5 plus 3. 4 plus 4. 4 plus 4. Thank you. 3 plus 5. 2 plus 6. And then 1 plus 7. Okay? Problem done. Okay? All right, really quickly, we're going to go over some basic rules that you should have learned when you were younger and that we discussed first semester. I am on the back of your paper very quickly. Anything to the power of 0 is 1. Hey, nobody said it wrong this class period. Good. So number 1 on the back is 1. Okay, anything to the power of 1 is itself. So number 2 is A plus B. Number 3, we're going to do the shortcut. So power of 2, what are the coefficients? Third row. 1, 2, 1. A to the second, then A, no A. B to the second, B, no B. Problem done. Because that's the beauty of the binomial theorem. The powers have to add up to the power that the problem is raised to. My first term decreases, my second term increases. So A2, A1, A0, B0, B1, B2. And I use the coefficients from Pascal's triangle. And later in the class, I'm going to show you how we can do it without Pascal's triangle. In previous years, when I gave a quiz, the kids would very quickly scramble to recreate Pascal's triangle to do these problems. I'm not going to torture you that anymore. Fatima. So, Pascal's triangle. X to the 0 is 1. X to the first, 1, 1. X to the second, 1, 2, 1. Those numbers are my coefficients. Good? Okay, so first term is A. So A to the power. Then decrease it. Then I came the other direction. B to the second. Decrease it. Yeah. Or just know that the A and the B powers have to add up to the original power. So 2 plus 0 is 2. 1 plus 1 is 2. 0 plus 2 is 2. Good? Questions? All right, we're going to put this to practice. All right, let's go ahead and begin. So, what is the Pascal row for x to the fourth? Coefficients. 1, 4, 6, 4, 1. Okay, my first term is x. So x4, x3, x2, x, no x. Go back the other way. y4, y3, y2, y1. You can double check. 3 plus 1 is 4, 2 plus 2 is 4, and so forth. Everyone good? Okay. Now the next one, I know some people ask questions, so just watch. We're going to do the same practice. Oh, I typed it wrong. This is a 6, isn't it? Okay, 6. So what are the coefficients for 6? 1, 6, 15, 20, then 15 again, then 6, and then 1. Okay? My first term is M. M6, M5, M4, M3, M2, M1, and then no M. And then I'm going to use parentheses because this is a number. So 2 to the 6, 2, 5, 2, 4, 2, 3, 2, 2, and then 2. Now we need to quickly do the math. And the math is 2 to the power 1 is just 2, right? 2 squared is 4. 2 to the third is 8. 2 to the fourth, 16. 2 to the fifth, 32. And 2 to the sixth is 64. All right, final answer. This is as complex as it gets, by the way. We have m to the 6. I have 6 times 2 because they're both everyday numbers. I'm going to do the math. 6 times 2, 12. 15 times 4, 60. She was doing the next one, or one of the future ones. 20 times 8, 160. 15 times 16, 240. Sorry, guys, the pen has a mind of its own today. Okay, and then 6 times 32, 196 or 92? 92, sorry. All right, let me undo that real quick. Okay, 192 m, and then we just have 64. Problem done. Now, yes, I think it's better to show out your work. It's up to you. Okay, so that would be the final answer. One more example on your paper. You should see x plus 2 to the 15th power, yes? Okay, so some people are like, you made us do that combination thing during the warm-up. I'm just going to use Pascal's triangle. Great. I'm going to give you a problem to the 15th power. Do you want to really write out all of those pieces? No. So let me show you. It asks for x to the 7th term. Okay? So it's going to be x to the 7th, 2 to the what power? How did you know 8? Because they have to add up to 15. Now, to get this front number, okay, it works out because Pascal's has that mirror effect, okay? So even though it's x to the 7th, 15, 14, 13, 12, and the 7th would actually be the 8th. The 7th and the 8th are the same exact answer. So we're just going to use 15 because there are 15 choices. Combo 7. X to the 7th is actually the 8th digit over, but 7 and 8 are the same answer because of that mirror effect. What did you get? The question says, what is x to the 7th? 6,435. What other math must I do in this problem? 2 to the 8th, which is 256. Now, what two numbers do I multiply together? This and this to give me one really big number. What is it? One, 6. So 1,647,360. The commas aren't necessary. I have to put them up there so I know how to read the number correctly. And then it's x to the 7th. Problem done. Okay, we're going to do one more of those, and then I'm going to tell you your homework. Good? Yes, sir? How did I get the x? In the question it says, find the coefficient x7 in the expansion. Okay? All right. The next question, ask for x9. Yes? So x to the 9th, negative 3 to the 2, because these two numbers have to add up to 11. I'm going to do 11C what? 9, which is 11 combo 9. 55. X to the 9th. What is negative 3 squared? 9. And 55 times 9? 495. X to the 9th. Problem done. Your homework is the back of the worksheet.